Hello everyone, welcome back to my channel. I am Bhavani, first year CSC student at Sri Venkateshwara College of Engineering, Bangalore. Today I am here with a new topic that is bisection method and Lagrange's inverse interpolation. Firstly, we're going to discuss what is bisection method. The bisection method is used to find the root of a polynomial function. For further processing, it bisects the interval and then selects a subinterval in which the root must lie, and the solution is iteratively reached by narrowing down the values after guessing, which encloses the actual solution. In this method, the interval distance between the initial values is treated as a line segment. It then successively divides the interval in half and replaces one endpoint with the midpoint so that the root is bracketed. This method is based on the intermediate value theorem and it's very simple and easy to implement. Finding root by bisection method. As stated above, the bisection method program is a root finding method that we often come across while dealing with numerical analysis. It is also known as bisection method numerical analysis. It is based on the Boltz's theorem for continuous functions. So, let us understand what Boltz's theorem says. Theorem: if an interval a, comma b and f of a, comma f of b is less than 0, a function f of x is found to be continuous, then there exists a value c such that c belongs to a, comma b, or which f of c is equals to 0. The graph given below shows a continuous function. The bisection method works iteratively by repeatedly dividing the interval in half and checking whether the function changes sign in each subinterval. The process continues until a sufficiently accurate root is found or until a predetermined stopping is met. Bisection method procedure. To solve bisection method problems, step 1. Choose two values a and b such that f of a is greater than 0 and f of b is less than 0. Step 2. Calculate a midpoint c as the arithmetic mean between a and b such that c is equals to a plus b divided by 2. This is called interval halving. Step 3. Evaluate the function f for the value of c. Step 4. The root of the function is found only if the value of f of c is equals to 0. Step 5. If c is not equal to 0, then we need to check the sign. If we replace A with C. If f of C has the same sign as f of A, then we keep the same value for B. We replace B with C. If f of C has the same sign as f of B, and we keep the same value for A. To get the right value with the new value of A or B, we go back to step 2 and recalculate C. The advantages of using bisection method: guaranteed convergence. The bracketing approach is known as the bisection method and it is always convergent. Errors can be managed, increasing the number of iterations in the bisection method always results in a more accurate route. Does not demand complicated calculations. There are no complicated calculations required when using the bisection method. To use the bisection method, we only need to take the average of two values. Error bound is guaranteed. There is a guaranteed error bound in this technique and it reduces with each repetition. Each cycle reduces the error bound by 12%. Disadvantages of bisection method. Although the bisection method convergence is guaranteed, it is often slow. Choosing a guess that is close to the root may necessitate numerous iterations to converge. Some equations roots cannot be found because there are no bracketing values like f of x is equals to x square. This rate of convergence is linear. It is incapable of determining complex roots. If the guess interval contains discontinuous, it cannot be used. Lagrange's inverse interpolation. Lagrange's inverse interpolation is a mathematical method used to find the value of an independent variable, usually denoted as x, given the corresponding dependent variable, usually denoted as y, and a set of data points. This technique is based on Lagrange's interpolation, which is used to approximate a function that passes through a set of given data points. In standard interpolation, we are given a set of data points xi, yi, and want to find a binomial function that passes through all points. Lagrange's interpolation accomplishes this by constructing a unique polynomial of degree n minus 1, where n is the number of data points that passes through all the given data points. However, in inverse interpolation, the roles of x and y are reversed. Instead of having the values of x and wanted to find the corresponding y values, inverse interpolation deals with having the values of y and seeking the corresponding x values. The motivation behind using Lagrange's inverse interpolation comes from various real world applications such as finding the roots of a polynomial equation when you have the function values at different points. This technique is particularly useful when it's difficult or computationally expensive to find the x values directly. Advantages of using Lagrange's inverse interpolation. Simple and easy to implement. Lagrange's interpolation method, including the inverse interpolation, is straightforward to understand and implement. It involves polynomial interpolation and the formulae are easy to compute. High accuracy with small data sets. For small data sets, Lagrange's inverse interpolation can provide reasonable, accurate results. Global interpolation. Lagrange's method ensures that the interpolation polynomial passes through all the given data points, providing a global approximation. Disadvantages of Lagrange's inverse interpolation. Numerical instability. Lagrange's interpolation can suffer from numerical instability, especially when dealing with a large number of data points or high degree polynomials. This can lead to significant errors in the interpolation results. Sensitivity to data points. The interpolation polynomials accuracy heavily depends on the placement and distribution of the data points. Distribution of data points can lead to inaccurate results. Accelerations for high degree polynomials, Lagrange's interpolation can lead to acceleration between data points known as the conjugate phenomenon. This can significantly impact the accuracy of the interpolation. Lagrange's inverse interpolation involves the following steps. Given data points xi, yi, calculate the Lagrange's coefficients for the corresponding y values. Use the Lagrange coefficients of the node y value to construct a polynomial function in x. Solve the polynomial equation to find the x value corresponding to the given y. It's important to note that inverse interpolation might not always have a unique solution. In some cases, there may be no solution or there may be multiple solutions for a given y values. Thank you for watching my video. Please like, share and subscribe.